Hey everybody, today it's the first time I will do a tutorial about the Raspberry Pi. So this is a live tutorial, so if you come to YouTube you can join the chat and yeah, you can ask questions directly. So welcome to this tutorial in English. In this tutorial I want to talk a little bit about motors and how they can be connected to the Raspberry. So I will talk about stepper motors, I will talk about small DC motors, and I will also talk about these small servo motors that I have here. I hope you can see it, it's already cabled there. And I want to show you a little bit the differences between them and what they can be used for, and also I want to explain you how they work and how you can control them and what hardware you need to make them work. Yeah, so let's get started. So join the chat, ask questions whenever you want. I will try to answer your questions regularly. So first I want to start a little bit with the small stepper motors. These are these little tiny motors that you can see here. They exist in different forms. This is the smallest one. It's a so-called Tower Pro 80 SG90 servo, and yeah, these servos are often used in RC cars. That's where they came from. And today many people use them to build small robot arms or stuff like this. And they are actually quite cool because they are cheap. You can get them for some cents or euros or dollars in RC car shops or in the internet. And they only have 3 cables to connect them. So I will make a small drawing so that you can see this a little bit better. So let's get a pen here. Let's take the black one. So on the servo you usually have 3 cables. As you can see here, you have a brown one, you have a orange one, and you have a yellow one. So these 3 cables are used to connect the servo to the Raspberry or the Arduino, it also works there, and also to give them power. The brown one is the ground. So this one has to be connected to the ground of the Raspberry. The orange one is 5 volt. So this has to be connected to the source of 5 volts. This can be the Raspberry, or this can be also a power bank like I have here. You also have 5 volts and ground there. And the last one is the signal to control the position. And the controlling of the positions works with a PWM signal. So I've prepared a little setup here, so you can see my oscilloscope now on the screen. Here you can see a little bit of floating voltage. This is because my power source is not the cleanest one. And when I start the program on the Raspberry, so the servo is connected to the power of the Raspberry, 5 volts and ground, and to 1 pin of the Raspberry, to the GPIO pins. And when I start the program, you can see a curve on the oscilloscope, which is getting bigger and smaller. This signal here, and this signal is actually saying which position to go. The servos internally have small potentiometer, and they always try to follow or to go to the position that you're telling them. To control the servos, as said, you need a PWM signal, and this PWM signal can be generated by the PWM library that is provided with the RPIO Python package. So I will just show you the example that I'm running on my computer. So as said, if you have questions, go to YouTube and join the live video, and then there is a chat and you can ask questions directly. So let's switch to my screen. So here you can see that I'm connected to the Raspberry, and I'm just running a small program called Servo py for Python. And when I edit the open the program, I hope you can read it, you can see that I only import the GPIO library here. I import the time library to have something like a timer, as you have seen, the servo made different steps. And then I declared one output to be an output actually, or one pin to be an output, so it's pin 17 in my case. And later I initialize the PWM control on this pin, in this case pin 17, and I'm giving it a PWM signal with 50 Hertz. And later in my script I'm only running in a loop, and in this loop I only change the width of the signal that you have just seen. So from 5 to 7.5, 10, 12, 10, 7, 5, 5, 2.5, and this is making the motor to move left and right. So actually these servo motors are really quite useful for robots, for example, and they are really easy to control. You don't need a lot of hardware, you just connect them to the 5 volts and to the GPIO pin, and then you can control them. But there's one big issue on the Raspberry Pi. The Raspberry Pi does not have real PWM output pins. So you have to use DMA, which is explained in the library for RPIO. So I will post the link also in the chat and later on in the description of the video. So the Pi has no real PWM output to control several steppers, and for this reason you need, if you want to control bigger stuff, you need something like a PWM driver, and they are available for cheap, for example from Adafruit. You can see this one is with the PCA 9685 chip, and here you can connect directly the up to 16 stepper motors directly to this small PCB. So you have also here the PWM signal, the voltage and the ground, as I have just shown in the on the drawing board. So you just plug them on to this small shield, and then you go. And to control it, there is a nice tutorial for this chip, for the PCA chip, and in theory you can go up to 992 servo motors, the small ones and the big ones, with only 2 pins, because this controller is connected via I2C to the Raspberry. It works with the Raspberry, it works also with Arduinos and so on. And you only need 2 pins to control it. You need the SDA and the SCL pins, and and of course the power. And to show you where you can find the pins, I really like the website which is called Pinout XYZ. And on this website you can find the output pins, the pin layout for the Raspberry Pi, and you can filter to see which one are for SPI, which one are for I2C, and you can see here the things to connect the small controller to are the pins 2 and 3. I always advise not to use the power directly from the Raspberry Pi as I just did it now, because if you have a lot of motors, then the current drawn by the motors can be high enough to blow the fuse on the Raspberry. So in this case it's better to work like this. You have the Raspberry with the I'll just have to switch down. So you have the Raspberry Pi here, and you have the GPIOs here, and you have the 5 volt input here. And instead of connecting the 5 volts from the motors here to the GPIO, it's better to add some sort of a splitter here. This can be a USB hub or something, or just if you use a power bank with 2 USB outputs, you use one output for the Raspberry, and on the other one you make a small cable, you cut the cable and then connect the red and the black cables to your servos, so that you have something. I just have to move the image of the oscilloscope. So up, so that you have something like this. So you have a sort of splitter box here. This can be something, yeah, like a breadboard, for example, or this can be just fiddled together. And then you connect the servos here with the signal and with the 5 volts and the ground. So you don't overload the Raspberry Pi when you have a lot of motors. You don't have to overload the Raspberry Pi and trigger the fuse. So as said, feel free to join the chat if you have questions. I will answer them. It would also be nice if you subscribe to my channel, because I will do this kind of tutorials more often in the future about all different topics that you are interested in. For example, also how to do LED stuff and so on. Yeah, so this are the first type of motors. So they can be controlled in the position where you want them, but they don't turn. There are versions that turn, but then you can only control the speed. So yeah, that's the first one. So just let me get rid of the drawings. I have to get something to wipe it away. This was the first group of motors. The second group of motors are so-called DC motors. So I have one example here. This is a DC motor. It only has 2 pins on the back, and this one has a gearing box in front of it. And to control this, I will just switch it on. So this motor works with 12 volt, as it's written here on the side. You can see 12 volts, and it's doing 5000 divided by 15 RPMs. So it's really a slow motor because of the gearbox, but because of this it's really strong, and I can't stop it because yeah, the gearbox, the transmission box, is doing its business. And these motors have to be controlled in a different way. If you only want to have this motor to turn into one direction and you want to switch it on or change speed, then you can use something like a so-called MOSFET, or yeah, MOSFET. And the MOSFET is actually something oh no, cool, there's the first question from Andrew. Is there any issue with the 3.3 volt control going to the 5 volt servo? So Andrew, no, I have not at the moment recognized any problems with this small kind of steppers, so I've only used this one until now. But no, actually there is no issue, or at least I have not discovered one. Perhaps on some digital, so-called digital servos, there might be a problem, but I have not faced a problem at the moment. So if you find out that you have such a problem, you can use a cheap level converter or just a transistor to push the level to the 5 volts. So yeah, back to the geared motors. To control these motors, you have also to use a PWM signal, because if you just want to switch them on and off, then you are fine. But if you want to control speed, you have to use PWM also. You have to use PWM also, and PWM means pulse width modulation. So if you have the motor, if you have output like this to the motor, it's turning faster than if it is like this one. As you can see, the pulses here are a lot more often than here. So this is the pulse width, and here the motor would turn faster, and here the motor would turn slower. As you have seen, this motor is a 12 volt motor. You can't connect it directly to the Raspberry. And to connect it to the Raspberry, as said, you need something like a transistor or a MOSFET. I hope you can see everything. I will just draw a quick schema here. So you have your Pi with the GPIOs, and from the GPIOs, I will just do it with a small transistor now. You have the transistor, Then you go up to your 12 volts, like for this motor, for example. Then you have your motor, and then you go to the ground. And to control this transistor, you need to add a resistor, not to have a high current on the GPIO pin. This can be something like 1K, for example, 1 kilo ohm. And then you connect also the ground to the Raspberry. And now you can control this motor with a transistor by using a PWM signal on the GPIO pin. So the same as I just said before with the GPIO library. Where is it? I have to bring it back to the screen. Here it is. Same as here, you just connect it to the correct pins, and then you can play with the timing and the pulse width of the PWM signal to make the motor turn faster or slower. But there's one issue. If you lower the PWM frequency and you have really a low speed, then the motor will also lose torque. Torque is actually the power. So yeah, you always have to be sure to use a motor which is strong enough to for your project. One advantage on these geared boxes is that if I turn off the motor, because of the gearing, I can't turn the axis if the motor is not powered. This is really useful if you want to lift something, or you have something that is not allowed to move when the motor is not moving. So this is a big advantage of motors with a geared box, that they block, and you always have the fixed position also if you have power loss. So for example, if you build something like a printer and you have a thing that moves up and down and you have power loss, then it will not move anymore and will stay at this defined position. So, okay, this was this part for the small DC motors. Now we are coming to the, in my opinion, most interesting type of motors. These are so-called stepper motors. So I have one of them here. They are looking like this, and I have another one, a bigger one. So you can see that they look quite similar, and the sizes is actually what you can find in the internet. If you search for NEMA 17 motor, then you will get this one. If you search for NEMA 23, you will get this one. But what does NEMA actually mean? NEMA is actually only the size of the motor. It says nothing about the power. It says nothing about the voltage. It only says that the motor has these dimensions. Just let me open one website to show it to you. So here you can see the NEMA sizes, and for example, this motor is a NEMA 17 motor, so it has this defined inch values. Oh, I hate it. So the size of this housing is roughly 47 millimeters. The dimensions here are always defined by this norm, and they only say something about the size. They don't say anything about the power. So if you have a motor like this, you always have to check if the motor has the power rating you want. On the motors, so there are different types. There are unipolar and bipolar motors. I will just talk about the most common used bipolar. There are 4 cables coming out of the motor, and this is because internally the motor has something like, it has a so-called anchor. I'll just draw it like this. I'm not the best drawer. And then there are some windings. in the motor. So there's one here and one here, and these are the 4 cables that come out, and for each winding there is one cable. And if you switch on this winding, then the anchor will be turned to this position. If you switch on this winding, then the anchor will be turned to this position. And this is how steppers work. They have multiple positions inside, steps. And on the data sheet of the motors, you can usually find a value like step angle 1.8 degrees. What does this mean? So if you do one full turn of the motor, you have 360 degrees. So 360 degrees is a full turn, divided by 1.8 degree means you have 200 steps, individual steps that you can position exactly on this motor. There are also motors with 0.9 degrees. This means you have 400 real positions on this stepper motor. And to control these stepper motors, you can use a H-bridge, which can be also used here if you want to turn it. I forgot about this. If you want to turn it forwards and backwards, I will come back on this later. Or you can use a decent stepper controller like these so-called Pololu step sticks, and there is a chip on side under the cooling here, which is a so-called A4988, and this chip has everything inside you need to control this stepper very easy. If you can control it also manually, but then you have to figure around which coil to energize and which coil not, and so on. And these chips really make it easy for you to control these stepper motors. Let me just show you a connection diagram, how they work. You can see one diagram here on my screen now. I will make it a little bit bigger. So you can see the small chip sitting in the middle. You can see the 2 coils in the motor, and you can see a power supply for the raspberry, and you can see a power supply for the motor, because these motors use really a lot of power. You cannot power them with the raspberry directly. On the PCB yourself, you have some pins which are called VMOD and GND. This is the power input for the motor's power supply, so 8 to 35 volts in this case. Then you have the windings, the outputs for the windings of the coils. You have an input pin called VDD for the power, to power the intelligence in this pin, and the ground, of course. And on the other side you have so-called pins like enable MS1, 2 and 3. MS pins are used to do some setups. I will explain this later. Then you have a reset and sleep pin, and you have the most important pins, the step and direction pins. So if you hook up the motor like you can see on the screen, you only need to know about the 2 pins that you actually use, so the step and direction pin. The step pin always says the motor to go 1 step further. So if you want to do a full turn, then you have to send 200 small pulses to the step pin, and then it will make the motor spin 200 steps, which means 1 complete rotation. And if you change the voltage on the direction pin, you can make it turn in the other direction. So only by saying 200 steps, you turn it clockwise, and then you change the voltage level on the direction pin. You put it high or low depending on your wiring. Then you can make it turn in the other direction, counterclockwise. Only with these 2 pins you can control really big machines like 3D printers. You can build robots with this, and you have a really exact positioning, because you always know how many steps have you done. If you have a wheel, for example, here on the motor, and you know the circumference of the wheel, then you can say by 1 rotation, 200 steps, you have done 10 centimeters of travel. So you always can calculate the position of your robot, for example. Or you can build a CNC machine, and everything by using this, by counting these steps. There are also libraries for steppers. You only have to Google Raspberry Pi Python stepper, and then you will find a lot of libraries that make your life actually easier, because you only say move forward to a position or move backward, and the library does the rest for you. What to say? Ah yeah, one point. With this so-called MS pins, you can also use so-called micro-stepping. As I just said, the stepper has 200 positions. But if you use this micro-stepping, you can divide them into halves, eighths, or even 16ths, depending on your setup. This means that you then have 200 times 2 steps, only because the controller knows how to power the coils inside to make steps in between. So you can have a more precise control of your motor or your robot or whatever. And there's only one disadvantage. If you use micro steppings, then you lose a lot of power, because if you have the 2 coils like this and you have them both energized to stay somewhere in the middle, you can always step one step further to really have it glued to the most powerful point next to a coil. So this is something you have to take into account. If you build something really heavy, you lose a lot of force or torque if you use the so-called micro-stepping. But if you use a gearbox or something, you can also deal with this. Yeah, that's about the stepper motors. Now back to the DC motors, as I just forgot. If you want to make this motor spin left and right, then you cannot only work with a MOSFET or a transistor, then you can use a so-called H-bridge. An H-bridge is called H-bridge because inside on in the controller it looks like an H. I will just show you one small image. It looks like this. So you have your motor sitting in the middle with the 2 connection pins, like I have here, red and orange, and then you have multiple so-called transistors also, which are controlled by the Raspberry. And for example, if you close pin S1 and pin S4, the motor turns into one direction, and if you close pin S3 or switch S3 and S2, the motor spins in the other direction, because the energy goes from the other direction through the coil inside the motor. So this is one way to control the motor. I actually ordered one of these bridges, but it didn't arrive in time. So one common known H-bridge driver is the so-called L298N. It looks like this. You can get these PCBs for cheap also on eBay, on Amazon, everywhere, and they are ready to control the direction of the motor. So you have, in most cases, you have 2 outputs, and you have the power input, the power ground input, and then the 5-volt input for the intelligence, let's say. And you can see here there are 4 small connectors, and these are the connectors that control actually the switches that I've just shown. So if you power this one and this one, it will turn into one direction, and if you power the other ones, it will turn into the other direction. So it's actually a small guy sitting in somewhere in this chip, opening valves or switches to make the motor turn left and right. Yeah, so to power the motors, as I have just said, you can use the 5 volts from the Raspberry, but you are limited because there is a small fuse on the Raspberry, protecting it against overcurrent and taking damage on the GPIOs. For this reason, it's always better to use an external power source to power the motors you have. If you need, for example, if you build a robot and you have a battery of 12 volt, what I'm doing, let's do it the other way. You have a battery with 12 volt, like a car battery or something really big. Then you add a voltage converter, so 12 volt plus in the ground. Then you add a so-called voltage converter, which gives out 5 volt for the Raspberry, and then you go to your Raspberry, and of course you also connect the ground. And for your motors, let's say you use something like a H-bridge, you connect the H-bridge directly to the 12 volt and also to the power, and then you go to your motor. In this way, you only take the small cable from the control signal to the motor driver, and the Raspberry Pi is really protected against overcurrent and over voltage. Yeah, actually it's like this. So if you have questions now, I see there are 6 people watching at the moment. Feel free to ask them in the chat. I hope I showed you a little overview about the technologies that exist. If you have questions, you can also ask in the Raspberry Pi group, and I would really be happy if you subscribe to my channel, because in future I will do much more tutorials about this. So please feel free to ask here in the chat now or later in the group. And yeah, that's the short overview I wanted to make about motors. I hope you have learned something, and yeah, I wish you otherwise a really nice weekend, and yeah, see you in the Raspberry Pi group. Thanks. Bye.